Okay, so for this problem, we have f of x equals 2x squared, and we're going to use the difference quotient, f of x plus h minus f of x over h, to calculate um, the difference quotient, or in this case, the slope. So what we need to do first is we need to find f of x plus h. So we need to replace this x in the 2x squared with x plus h. So when we do that, we're going to get x plus h. Again, just trying to emphasize that's what we're plugging in. Okay. So once we have that, that's basically the hardest part is setting this up. So we have that. We have f of x plus h, which is the 2 times x plus h squared. And we have f of x, which is 2x squared. So I'm going to put that in there, replace those from the information that we just obtained. Okay. All right. Then our next step is to expand this information. And if we did it correctly, then all of our a lot of our terms are going to cancel out. So the x plus h squared, you'll see that a lot, especially if we're working with something with x squared. So I'm going to show you two ways to do that. Okay, so this is going to be my scratch work. So x plus h squared means you multiply that 2 times, right? And you can use the FOIL method or the distributive method to find that. We talked about that before. So I'm going to have x times x plus h times x plus h, right? And I distribute that x and then that h. So that gives us x squared plus xh plus xh plus h squared, which is x squared. We have two of these, so that's 2xh plus h squared. All right, so that's one method. The other method is if I have if I have any type of factor and it's just um, being squared, what you can do is you can take that first one, the x, and square it. You can take the second one there and square it, and then you multiply the two. So that would be what? xh, right? X times h is xh. Then you just double it. All right, and then it's addition, so everything is just positive, and you get the exact same answer. So again, whatever you feel comfortable doing, but since I already know this, instead of going through all these steps, I just do that little technique. All right, and then once you have that, then we can just plug it in here. So this first part, we have 2 times, and we got x squared plus 2xh plus h squared minus 2x squared divided by h. Now, if we distribute that 2, okay, we distribute that 2 to each term, then we're going to get, I'll do it over here, 2x squared plus 4xh plus 2h squared minus 2x squared divided by h. And as I mentioned, if we did this correctly, then a lot of the terms will cancel out. So the 2x squared are going to cancel. And then we have xh plus 2h squared divided by h. And what is our goal? Our goal is to eliminate h in the denominator. Okay? Which is this sucker right there, or this one right here. All right? We need to get rid of that denominator because that's what's causing us problem. Okay? So we're able to do that. All right? So we can factor out the h here. So we have equals 4, sorry, equals h times 4x plus 2h divided by h. And then this h here is going to go away, leaving us with 4x plus 2h. Okay, so now let's think about what this means. Okay, so I call this the slope generator. Remember, this whole difference quotient is just a fancy way of saying the slope. Okay, it's more, it's a lot deeper than that because you can apply it to a lot of things, but it's the slope or the average rate of change, or in this case, the instantaneous rate of change. Okay, so I call this here the slope generator. You probably will never see that in a textbook, but that's what it does. So what do I mean by that? So remember we talked about back here, uh, when we found this here, the very beginning, we had the limit as h approaches 0, right? This is a part of the formula we're missing. It's this portion here. Because in the end, what we need to do is we need to plug in that 0. So that's why that h in the denominator causes issue, is because when we replace that h with 0, we can't have a 0 in the denominator. So that's why you want to get rid of this h. That's the goal. So anyway, so that's what's missing. That's what's missing there. So if we were to go here, right? And again, I'm going to rewrite this here, the 4x plus 2h. That's what we got. Anyway, this is the answer you would put in the lab work. That will be the answer. But again, let's just focus on that a little bit so you have an understanding what that means. So the limit as h approaches 0 is 4x plus 2h. That's what we got. This whole thing here, this whole thing right here that we just did equals this. Okay? That's what it equals. So when we have this here, then we plug in our value for h. So that becomes 4x plus 2 times 0, which is 4x plus 0, which is 4x. Okay? So again, what does this mean? I call it the slope generator. We have the function f of x equals 2x squared. And we're going to learn a bunch of these graphs in 3.5 or okay, or 3.4. So 2x squared is a parabola, and it's a happy parabola because it's positive 2. So it just looks something like this. Okay, again, it's like something like that, right? This is what the parabola looks like. So if you give me any value for x, so let's say that x is equal to 3. Okay, so that's saying, okay, what is the slope? That's the question. What is the slope when x is equal to 3? So again, this is called a slope generator. So the 3, so if I mark it here, 1, 2, 3 is right there. All right. So if I draw a tangent line, right? A tangent line means it just touches it at one particular point. So at this particular point here, okay, what is my slope? What's the slope here, right? Or m. So if we use this formula, well, we know it. So m is 2 times x squared, right? So then we just plug in 2 times 3 squared. So that's going to be 3 squared times 3 squared is 9 times 2 is 18. So in this case, when x is equal to 3, the slope is 18. And that's the beauty of this difference quotient is that you give me any point on this graph, and I can tell you exactly what that slope is. So instead of picking 2 points every single time, now we have a function, we have something we can just plug in and it will, spit out information for us that we need. But anyway, so that's the behind the scenes that many college algebra students don't know. They just see this part and they're like, what the heck does that mean? All right. But that's what's happening when you get to the next step. Once you apply that limit. But anyway, but I'm just trying to inform you what's happening here so you have an idea what we're doing here. Okay, anyway, but in the bottom line is the answer to this question is 4x plus 2h. Okay? Okay. So let me just backtrack what I said here. The 2x squared, right? The 2x squared, oops. The 2x squared represents this function, right? So this graph, the parabola. So I apologize, and I used that instead of what we found. So let me erase that here. So we just found the 4x plus 2h. So that's what we need to do. And we plugged in 0 for h, which gave us 4x plus 0, which is just 4x. So I meant to use 4x instead of 2x squared. So anyway, so we plug that in there for x and we get 12. Okay. So that's what we wanted to do. Not the 2x squared, because again, the 2x squared is telling us what that graph is. But we need to use this one to figure out what the actual slope is. But before we can do that, we have to plug in 0 for h, and that will eliminate the 2 times h, and then we'll get the 4x, and then whatever value they give us, because they'll say, calculate the slopes at these points, 1, 2, 3, 5, 7, -10. So it'll be, you know, a limited amount of slopes, and it's just easy to just find the slope generator. And so in this case, which was this, or the 4x plus 2h, and start plugging in those values. So anyway, that's what we need to do for that. So please make that correction. Okay, so here we have f of x is equal to x squared minus 5x plus 8. And so we also need f of x plus h. So that's going to give us, so anytime we see an x, we're going to replace it with x plus h. So we'll have x plus h squared minus 5 times x plus h plus 8. Okay. So then we're going to use the difference quotient, which is f of x plus h minus f of x all over h. Okay. And then we're going to replace our f of x plus h by what we just got here, and replace f of x by this information here. Okay. Again, if we do this correctly, then things will start canceling out. So we have x plus h squared minus 5 times x plus h plus 8. And we have to be careful here because it's a minus, right? This is a minus the whole function. So we have to be careful that this thing is, this part has to be, is subtracting this whole thing. So we put x squared minus 5x plus 8, right? So subtracting that whole function there, not just the x squared, but that whole function. And then this is all being divided by h. Okay. Then I just start multiplying things out. So as you notice, we see the x plus h square again. Again, anytime we have a square, we go through that, multiply the two factors or use the FOIL method or distributive method, or you can just do the little trick where again, you square the front, you square the back, you multiply the two, and then double it. So x times h is xh, then double it, it becomes 2xh plus h squared. Again, if you don't feel comfortable doing that, go ahead and FOIL those two out by multiplying x plus h times x plus h. And then this negative 5 is distributed, so that becomes negative 5x minus 5h. And then we have the plus 8. Then this negative 1 is also distributed, so that becomes negative x squared plus 5x minus 8 divided by h. All right? So I mentioned earlier, what if there was x to the 10th power? Wow, that's going to take you a long time to multiply that out. Okay? So now we can start eliminating our terms. The x squares are going to go away. The 5x are going to go away. The 8s are going to go away. Okay? So, and hopefully the terms that you have will only have the h's because again, we have to get rid of the h in the denominator. So this becomes 2xh plus h squared minus 5x divided by h. Okay. And then we're going to factor out the h. Then we've got backtrack again here. That should have been a h, not a 5x over h. Okay, so now I have h times 2x plus h minus 5 divided by h. Okay, and then this h will cancel, and this is what you would enter in the lab. Okay. Okay, so for this next example, we have f of x is equal to 1 over 2x. So again, we need to find the other component. So f of x plus h. So anytime I see an x, I'm going to replace it by x plus h. Okay. Then we're going to use a difference quotient, f of x plus h minus f of x all over h. And then we're going to replace these two terms here by what we just obtained. So we have 1 over 2x plus h minus 1 over 2x divided by h. Okay. Now, what I like to do in these types of problems is I like to solve them by parts to organize my information. So I'm going to focus on the numerator here first. Okay. So I'm going to write my scratch work on the side. So I have 1 over 2 times x plus h minus 1 over 2x. Okay? So remember, just like as we're subtracting fractions, we need a common denominator in order to subtract them. Okay? So, for example, if we have 1/2 minus 1/3, our LCD is 6, right? Because 2 times 3 is 6. So I need to multiply this by 3 over 3 and multiply this by 2 over 2. So that gives us 3 over 6 minus 2 over 6, which is 1/6. So again, in order for us to subtract or add fractions, we have to have the same common denominator. So that's what we're going to do here. So I have 2 times x plus h, and I have 2x. So that means then I need to, I'm gonna move this here. Okay. That means then I need to multiply these by factors so that we'll have the same common denominator. So our LCD in this case is 2x and then x plus h. Okay, and that's going to be our LCD because we have the 2x here and we need the x plus h. We already have a 2, all right, so we don't have to say that again. So those are the three parts we need, okay? So 2x, 2, the x, and the x plus h, all right? So then that means that I need to multiply this by just x, right? This one here, because I need 2x in the denominator. So x over x, and then this one here, I need to multiply by x plus h. Okay. All right. So that gives us x over 2x times x plus h minus um, x plus h. I'm going to put that in parentheses divided by 2x times x plus h. Okay, so I have a negative here, and I put this in parentheses to let me to remember that I need to distribute that negative to each of my terms. So I'm going to have, again, x, I'll just write it out for right now, x minus x plus h divided by our denominator, 2x times x plus h. Now, sometimes I see this and don't do this, so students will say, oh, I have x plus h, I have an x plus h, I'll cancel that. Oh, I have an x, I'll cancel that with this x. Don't do that, okay? That's not correct, all right? So what I need to do is I have that -1 and I need to distribute that. So I'll have x minus h all over 2x and then x plus h. Okay. So then in this case, my x's go away and then I'm left with -h over 2x times x plus h. Okay. All right, but I'm not done because again, this is just the numerator. That's just the numerator. So now we need to plug this information for the top. Okay, so that's going to give us, no, we'll use a different color here. -h over 2x times x plus h divided by h. Okay. All right. So again, I know these problems are tough because it really tests your algebra skills, your simplifying skills. So, but if you get through this, it's probably the hardest problems we'll ever do in this class, because they're so involved. Okay. So, but if you get through this and you understand it, then the rest of the class is going to be not as difficult. Okay. So anyway, so let's go ahead and take this information here and move that there. And I'll delete that. All right, so this is what we have. Okay. So remember h, okay, dividing by h down here is the same thing as h over 1. So I can write this as h over 1. then I can just rewrite this as negative h over 2x times x plus h divided by, or sorry, times by 1 over h, right? So if I had 2 over 3 divided by 5, right? I can rewrite 5 as over 1, and then I keep the 2/3, and then my division becomes a multiplication, and then I flip the 5/1 to 1/5. That's exactly what I did there. Okay. All right. Same process. So that's what I tell students is that if you get stuck, go back to what you know. How would I do this in if it was just a simplified fraction form? How do I do that? How do I rewrite it? Okay. And that's what I do. Okay, so now we can start simplifying this. And so the h's are going to go away. Then we have -1, don't forget that negative there, over 2x and x plus h, right? And again, there is your answer there. I know it looks complicated, all right? But again, the information that we're missing here is that h goes to 0, and then if they give us a value for x, then we can find the slope of this function. Okay, so in this case, I have f of x is equal to the square root of x minus 1. So we need f of x plus h. So anytime I see an x, I'm going to replace it with x plus h. So this is going to give us x plus h minus 1. Okay, so these are the two types of information that I need to plug into my difference quotient. Okay, so f of x plus h is going to be this here. And then f of x is the square root of x minus 1 divided by h. Okay. Okay, so in this case, our goal here is to get rid of the radical. And there's a couple ways to do that. One is if we were solving an equation, we can square both sides and we can get rid of the radical that way. But in this case, we're not solving for a particular variable. We're simplifying, so we can't just square this, right? We can't just do that because it's not going to be the same thing. The right side does not equal the left side. All right. And then don't dare to do this because, again, that is not correct. Okay. So, so another way to do it is, as I mentioned, if you have 2 over radical 5, I can multiply the top and bottom by radical 5, and that will get rid of the radical in the denominator. And I can do the same thing if I had a radical on the top. I can multiply the top and bottom by the same radical because it's like multiplying by 1 because radical 2 divided by radical 2 is 1. So I haven't changed anything. Okay. So that gives me 2 over 5 radical 2, right? 2 over radical 5 is the same thing as 2 radical 5 over 5, and radical 2 over 5 is the same thing as 2 over 5 radical 2. All right. So they're equal. And anyway, this is called rationalizing the denominator for the top and then rationalizing the numerator for uh, the top. I'm sorry, rationalizing the denominator for the top part here and then rationalizing the numerator for the bottom part. But in this case, we're going to do something similar and instead of calling it rationalizing, we're calling it multiplying by the conjugate. So remember, if you have a squared minus b squared, that is, if you were to write the formula for this or factor that out, that'll be a minus b and then a plus b, right? So if we multiply this out, it gives you a squared minus b squared. So if you had x squared minus 9, that factored into x minus 3 and x plus 3. So if you had x minus 3, the conjugate would be x plus 3, and vice versa. If you had x plus 3, the conjugate would be x minus 3. Okay? So in this case, what we're going to be doing is we're going to multiply by the conjugate. So we have the square root of x plus h minus 1 by the square root of x minus 1. So that means then I'm going to multiply by the conjugate, which is the opposite of this. So that first term is going to stay the same. But instead of having a minus 1 in the middle, now we're going to have a positive. Okay? And then still have the square root of x minus 1 divided by, again, it's like multiplying by 1, so that means we got to do it again for the bottom. Because again, this whole thing here is equal to 1, so I'm basically multiplying by 1. All right, so notice that, again, we have, this is going to be my a minus b, and this is going to be my a plus b. Oops. Okay, so um, that's just the difference quotient, and that's why we're using this. That's why we're using this here, this formula. Now, again, if you don't feel comfortable doing that, again, you can multiply this whole thing together, which gets really complicated if you want to. Okay, I like to use a formula to make my life easier, so I'm going to use it. So in this case, then, um, I'm going to rewrite this as the square root of x plus h minus 1 square minus the square root of x minus 1 square. Okay, why can I do that? Because I just mentioned that these are being multiplied together, all right? And then when you apply the rule, you get this information. So the top part here is the right side of the information, and then what we got here on the second here line is this part of the information. Okay, so that's wonderful. And then we have that whole denominator still. And I'm going to represent this sucker here as D. Okay, so I'll have HD, so I don't have to keep writing that whole big thing. Okay, so okay, so let me erase this down here. All right, so now we have um, the radical and the square, so they're going to cancel. Okay, so this is cancel with that, and then the radical and the square goes away. So we have x plus h minus 1 minus, again, put this in parentheses, x minus 1, and I have hd. Again, that d represents this bottom portion of the denominator. So to kind of just simplify it, and I don't have to keep writing that whole thing out. Okay. All right, so now we just simplify. So we get x plus h minus 1 minus x plus 1 divided by hd. Again, I just have a negative one here, so I distribute that to each term. Okay, and then I can cancel some information. So the x's go away, then the ones go away. So then we're left with equals h over hd. And then the h's go away, leaving us with 1 over d. Okay, now we know what the lowercase d here is, and that was, we represented it by this term. So we're just going to replace that back, substitute that information back. So we have the square root of x plus h minus 1 plus the square root of x minus 1. And then that will be our answer there. Okay, so in this section, we're going to talk about properties of functions. And in order to do the properties of functions, we need to understand these two important concepts, an even function and an odd function. So an even function, an example would be like f of x equals x squared, okay? And the graph looks like this. So as you notice the graph, the orange graph here, again, this is a parabola, and it's positive, so it's a happy parabola. You notice that there's symmetry. It's symmetric by the y-axis. So another way to say that is it's reflected over the y-axis. Okay? So if it's like looking in the mirror. Okay, and the mirror is the y, and each side is the same, right? So that's why they say it's symmetric by the y-axis, or it's reflected over the y-axis. In regards to this odd function, and a specific example will be f of x equals x to the third power. And notice you have symmetry by the origin because the origin is in the middle, right? So this upper half of the graph, top right, is reflecting over the bottom half, all right, through the origin. Or it has rotational symmetry. So if you rotate it, you'll get the same graph over and over and over. Okay? So that's what that information there is talking about. Now, let's explore a little bit more about what it means to be an even function and an odd function. So if we have here f of x equals x squared, right? So f of x is equal to x squared. And um, if I pick, say, um, 2 points. So let's say I have a positive 3 and I have a negative 3. What's going to be the output? Okay. So if I plug in f of 3, I'm going to have 3 squared, which is 3 times 3, which is 9. If I plug in negative 3, I'm going to have negative 3 squared, which is negative 3 times negative 3, which is also positive 9. So these points here, right, 3 and negative 3, if I were to plot those on the um, graph here, they're going to have the same y value. In this case, 9, right? It spits out 9. So they get the same y value, okay? The same y value, all right? So when x is 3, the y value is 9. When x equals negative 3, the y value is 9. So all the way across there, okay? So what does that mean? That means then if we were to find out whether a function is even or not, we just need to plug in negative x. So if I plug in a negative x in here, let me do it on this side here on the right. If I plug in a negative x for my function, I'll have a negative x squared. And that's going to give us a negative and a negative. So this would be a negative 1 square, and then you have x squared, right? If you were to break that down. So that negative 1 square will be a positive, and you still have the x squared, right? So that will be a positive x squared or just x squared. Okay? So notice that at the end, we get the same output. Okay? We get the same output for our original function and when we plug in the negative x for the original function. So the bottom line here is if we have the same output, okay, then that means we have an even function. Okay, we have an even function. Now, let's talk about odd symmetry. And let me use a different color there. Okay, so for the odd symmetry, we are using f of x is equal to x cubed. And I'm going to go through the same process again. Okay, I'm going to plug in positive 3 and negative 3. put it out here. Okay. Positive 3 and negative 3. So if I have f of 3 and I plug it in for my function, x cubed, okay, we're going to get what? 3 times 3 times 3, which is 27. If I plug in negative 3 for my function, that's going to be negative 3 to the third power, and I'm going to have a negative 27. Okay, so here at 3, somewhere up here, we get 27. We plug in negative 3, somewhere on here, we get negative 27. Okay, so notice then we have a positive and then we have the opposite, negative 27. So if the output is opposite, okay, what does that mean? Well, again, in order to determine whether it's an odd function, we're going to go through the same process of plugging in the negative x. Okay, so we have f of negative x. So that would be negative x to the third power. And that's going to give us negative 1 to the third power times x to the third power. And negative 1 to the third power is just negative 1 times negative 1 times negative 1, which is a negative. And then we have x to the third power. Okay. So what does that mean? Well, notice again, these are opposite. If I have a positive x cubed for my original, when I plug in a negative x to my original function, it gives me the opposite. It's a negative now. So the bottom line here is we have the opposite output. Okay. Then we have an odd function. It's an odd function, right? Now, you can say, well, it's x to the third, that's an odd number, so that's an odd function. It's x to x squared, that's an even function. It's true, you're correct. However, what if there's other terms added to it, right? X to the third plus x squared plus 1, x plus 1. Is it even or odd? All right, or maybe it's being divided by another term, x to the fourth or x to the fifth. Is it even or odd? So again, it's for these ones, yes, it's pretty cut and dry, but if you add other terms to it, it gets complicated, and that's what you need to do is you plug in that negative x to determine if that function is even or odd, or sometimes it's none of it, neither. Okay, so anyway, that's a great segue to what we're going to do, right? It's basically do problems and figure out whether the function is even or odd or neither. Okay, so in these problems, they want us to determine whether it's an even, odd, or neither function. So to determine whether it's even or odd, we just plug in negative x. Okay, so if it spits out the same output as the original function, then it's an even function. If it spits out the opposite, meaning one is positive, one is negative, that's the only difference, then it's an odd function. But if it doesn't do any of that, then it's a neither function. Okay, so we have f of negative x equals 4 times negative x to the third power. Okay, so I'm just going to break this down. So we have 4 times the negative x, that's negative 1 times x, or I can write it as negative 1 to the third times x to the third. Okay, so that is 4 times negative 1 to the third, that's just negative 1, because it's negative 1 times negative 1 times negative 1, which is negative 1. And then we have x to the third power. Well, 4 times negative 1, that's just going to give us negative 4, and then x to the third. Okay, so now what do I do? Well, we need to look at our outputs. Okay, so for this one, we have our original function, we have 4x cubed. And then our when we plugged in negative x into our function, we get an output of negative 4x third. So notice that the original is positive, and when we plugged in negative x, it gave us a negative. Everything else is the same, but the only difference is we have a negative now. So these are opposite, okay? So these are opposite outputs. So that means, right, we have opposite outputs. So that means this is an odd function, right? It's an odd function, okay? All right. All right. So again, what we need to do here is we need to plug in a negative x um, for a function. So we have g of negative x. So negative 3 times negative x squared minus 5. Well, the negative x squared, because it's being squared, that's just going to be positive, right? So we have the negative 3 still in the front, and then this will become just x squared. The negative 1 squared is a positive, will give us a positive. And then we have the minus 5. All right, so here's our original function. Here is the output when we plugged in negative x, and we get the same. So that means then this here is an even function. Okay, so it's an even function. All right. Okay, so then we're going to do exactly the same thing for this one, right? So I'm going to plug in the negative x in. So that'll be 1 over negative x squared. And so negative x squared is just going to be a positive x squared. So that'll be 1 over x squared. So again, I look at my original function and I look at the output after I replace x with negative x, and I still get the same output. So this one as well is an even function. Okay. Okay, so again, we're going to plug in negative x into our function. So we're going to have h of negative x, which is going to be negative x over negative x squared minus 1. So we still got negative x on the top, and then the negative x squared just becomes x squared minus 1. Okay, so now I can write it this way, or I can have the negative in the front and have x squared minus 1, or I can have the negative also in the bottom and have x squared minus 1. Okay, so this one here, as well as this one here are all the same. You can write it in those three different ways. Okay, I could have the negative on the top, the negative in the middle, or the negative in the bottom. They're all the same. But we just have to understand that this is just going to be opposite, right? Because this is a positive x over x squared minus 1, and we have a negative x over x squared minus 1. So in this case, our conclusion here is we have an odd function. Okay, very good. Okay, so again, we want to determine whether each of these functions is either even, odd, or neither. And so before we do that, let's explore the negative. So if I have the cubic root of negative 1 versus the square root of negative 1, right? So if I look on the inside here, negative 1, and my root is 3, so that means I want to match this root with the power inside. So what I mean by this is that I want to multiply this number negative 1 3 times so that it spits out a negative 1. So negative 1 times negative 1 times negative 1, okay, is going to give me a negative 1, right? So I can rewrite this as negative 1 raised to the third power, okay? Because again, negative 1 times negative 1 times negative 1 equals negative 1, right? So negative 1 to the third is the same thing as is equal to -1. So I can rewrite that. So in this case, then I'll have the cubic root of -1 to the third. Okay, because again, this here is the same thing as what we as we rewrote it. Okay, they're the same thing. So that means then I can get rid of the root here and the power, leaving us with -1. So it works. Okay. However, for this one, we want to multiply, since we have a root of 2, we need to multiply something twice, but it spits out a -1. So if I have -1 times -1, it doesn't spit out a -1. It spits out a +1. Okay? So a -1 square spits out a +1, but I want a -1 because that's what I'm looking for. So it's not possible. Okay? We can't find a -1 multiplied to itself twice that will give us a +1. So that's why in this case, this is again not possible. All right, it's not possible. You can't take the square root of -1 in the real world. So we're going to apply the same thing over here. So in this case, we have f of -1, so the cubic root of -1. So again, I can rewrite this as -1 raised to the third power. I'm sorry, let me backtrack. I meant -x, not -1. So cubic root of -x. And then I can rewrite this as -1 raised to the third power, and then x to the third. Or in this case, just x. Okay? So I can break this down as the cubic root of -1 to the third times the cubic root of x. Okay? So in this case, the cubic root and the cube are going to eliminate. And then that means we only have a negative in the front, and then we have the cubic root of x left over. Okay? All right. So notice we have a positive cubic root of x, and then we have the opposite of cubic root of x, which is the negative. So in this case, we will have an odd function here. Now, let's do the same thing for the square root of x. So we're going to have f of -x, take the square root of -x. Again, I can break this down to -1 squared times x and take the square root, right? However, -1 square is not -1. It's +1, right? So, but I want a -1 in the front. So I can't do it, right? Because I have a +1 and I need a -1. So in this case, it's not possible. So this one is neither. Okay. So we want to find the average rate of change, slope, speed, whatever you want to call it. Um, we have the function f of x is equal to -2x squared plus 4, and we're going to go from 1 to 4. So we want to find the average rate of change from 1 to 4. So how do we do that? So we need the formula. So we know the slope formula. Slope formula is y2 minus y1 over x2 minus x1. That's the slope formula. Another way to rewrite the slope formula is by f of b minus f of a over b minus a. Okay? They're exactly the same thing. So I'm going to start labeling these. Okay? So this will be my a. and this will be my b. Okay? So when I plug this in, we're going to have f of 4 minus f of 1 over 4 minus 1. Okay? So again, a to b, that's 1 to 4, and then I plug those information in. So now I need to find what is f of 4 and what is f of 1. Well, I have my function. Here's my function right here. Okay? That's my function. So I need to use that information to find out what is f of 4 and what is f of 1. So we're going to have f of x is equal to negative 2x squared plus 4. And we're going to plug in f of 4. And then we're going to plug in f of 1. Okay. So f of 4, we're going to have negative 2, 4 squared plus 4. And f of 1, we're going to have negative 2, 1 squared plus 4. Okay. So we're going to have negative 2, and then 4 squared is 16 plus 4. So negative 2 times 16 is negative 32. And then plus 4 will give us a negative 28. The bottom here, we're going to have 1 squared is 1 times negative 2 is negative 2 plus 4 is going to give us, so have what? Negative 2 plus 4 is going to give us a positive 2. Okay. So then I just plug in that information. For f of 4, we got negative 28. And then for f of 1, we got 2. And then the bottom is still 4 minus 1. Okay. So the top, we're going to get negative 28 minus 2 is going to give us a negative 30. And then 4 minus 1 is 3. So we just simplify that, and that gives us negative 10. Okay, so that will be our answer there. All right. So again, what's the average rate of change? Is negative 10. Maybe the person was driving and they're decreasing their speed by negative 10 miles per hour, slowing down, something like that. Okay. But in this case, the average rate of change is negative 10. Okay, so again, trying to find the average rate of change of this function from negative 3 to negative 2. All right. So we're going to use the formula f of b minus f of a over b minus a. So we're going to have, so this is going to be a to b. So we're going to have f of negative 2 minus negative 3, f of negative 3 over negative 2 minus negative 3. Okay, so let's go ahead and plug this information in. So we have f of negative 2, so that'll be negative 2 cubed minus 2 times negative 2 plus 1. So when we put that in the calculator, we should get negative 3. Then we have f of negative 3, which will be negative 3 cubed minus 2 times negative 3 plus 1. So if we put that in the calculator, we get negative 20. Okay, so we just plug that information in. So f of negative 2 is negative 3 minus f of negative 3, which is negative 20. Okay, and then we have the negative 2 minus negative 3. Well, let's rewrite this. Two negatives are going to give us a positive, so that's going to be negative 3 plus 20. Same thing here, so this could be negative 2 plus 3. So the top part there, we're going to have negative 3 plus 20, which is 17, and negative 2 plus 3 in the bottom is going to give us 1. So 17 divided by 1 is 17. Okay? Okay, so we want to find the average rate of change from 2 to 4, and then for part B, we want to find the equation of the secant line containing 2F2 and 4F4. Okay, so part A, we're going to do exactly what we've been doing. Okay, so part A, we're going to have F of B minus F of A over B minus A. So in this case, Um, this is A to B, so this is going to be F of 4 minus F of 2 divided by 4 minus 2. All right, so F of 4 there, we're going to have 4 squared minus 2 times 4. And when we put that in the calculator, we get 8. For F of 2, we get 2 squared minus 2 times 2, which gives us 0. Okay, so the top there we get 8 minus 0, and the bottom we have 4 minus 2, which gives us 8 divided by 2, which is 4. Okay, all right, so now let's talk about part B. Find the equation of the secant line containing those two. So again, as you notice, this is my A, right? And here's our B. So this is going to be F of A, and this is our F of B. Okay. So first of all, let's talk about what the word secant line means. Okay. So if I have say a circle, all right. So if I want to find out what the tangent line is, I would draw a line on that circle and it touches it at one point, right? So this would be a tangent line. However, if I draw another line and it goes through to two separate distinct points, so here and here, okay, this is called a secant line. Okay, so that's what they're asking. What is this equation what is this equation of this secant line? So we have some parabolic shape, right? So I don't know where it is. It's some kind of parabola, and we want to know from, say, 2 to 4, what is that equation? So, maybe it's looks something like this. Again, this is not the best um, representation or best drawing. But anyway, so from 2 to 4, I want to find out, okay, what is that equation of the secant line? So I'm going to show two ways to do that. Okay. The first way I'm going to show it is by the point slope form. Okay. So, um, let's get this information here. We need that. Okay, let's try one more time. Okay. So, do I need this information? Let me see if I can delete those. Okay. Okay. So here's our F of B. All right. So, again, I'm going to show two ways. Method one, is the point slope form. So point slope form. Okay. So that's just a y1 minus y minus y1 is equal to m times x minus x1. Okay, so that's going to be the point slope form. And this is my preferred method. Again, it doesn't matter which one you do. In the end, you get the same answer. But so now I can plug in my information and I can pick one of these points. So I can pick this point here, or I can pick this point here, right? And it doesn't matter because they're on the same line, so we're going to get the same exact answer. So let's just do the one on the left because it's smaller numbers. I like working with smaller numbers. So that f of 2 was 0, right? F of 2 was 0. So this is 2, this coordinate here is 2, 0, right? That's what we found out from here. F of 2 is 0. So that's one coordinate. And this one here, F of 4, right? So we have 4, F of 4. So F of 4, we found out was 8. So F of 4 is 8. Okay? So that's just a fancy way of saying when X is 4, what is F of 4? 8. 4, 8, and 2, 0. Okay? So as I mentioned, you can choose either one. It doesn't matter. So I'm gonna do the first one here because it's easier to work with. Plus there's a 0, which is great. So I have y minus y1. So this is x1, y1. So my y1 is 0. And then we have m. So let's go back here. M was 4, right? That was our slope, 4. So this becomes 4 times x minus x1. And then y minus 0 is y, and I can distribute that x inside that 4. Uh, there we go. Okay, so y minus 0 is y, and then I distribute that 4. That gives us 4x minus 8. Okay, and then so that will be our answer there. So this is the equation of the secant line. So I'm going to show another method, as I mentioned before. So method 2. If you don't like that method, then you can use the slope-intercept form. Intercept form. Okay, so that's just a y is equal to mx plus b. Okay, so again, you can choose either one. I'm going to choose this one again, the 2, 0, because it has 0 in it, smaller numbers, easier to work with. So I am looking for my b. That's what I'm looking for. So I have y is 0, I have m was 4, that's what we figured out, and then x is 2. Okay, plus b. All right, so we got 0, and then 4 times 2 is 8 plus b. So minus 8, that goes away. We have negative 8 equals b. All right, but you're like, wait, I got a b here. We're supposed to get an equation. Okay, well, we do. So we're just going to rewrite this as y is equal, and we already know our slope, which was 4, and then x minus 8. Okay, so that will be our answer here. So again, just use two different methods. You got the point slope form, and then we have the slope intercept form. But at the end of the day, we get the same answer. Okay, so for this section, we just need to match the graph with the appropriate function or the name for it, and then write a general the general standard equation for that, a graph. Okay, so the first one here is a V, so you should think about the absolute value, right? This is an absolute value graph. Okay, so for this one, um, this one we should have f of x is equal to the absolute value of x, and that corresponds. Um, this would be a here. So if you were to follow this, that would be a. Okay. This one, part B, okay, is your quadratic. That's your quadratic function. And the general equation or form of that will be x squared, or f of x is ax squared plus bx plus c. Okay, so this is the absolute value up here, and this is the quadratic. And then that would be the answer if you were to fill this out would have been B for that quadratic. Okay, so for the next one here is a cube function. So let me use a different color. So we have a cube function, and um, we can write that as f of x is equal to x to the third power. The next one here we have, so for that cube function, that would have been c. All right, if you're following this handout. Um, the next one here, hopefully you're familiar with that one. That is the square root. This is the square root function, or radical. Okay. And for the radical there is f of x is equal to this the square root of x. And that would have been letter D. Okay. All right. Let's keep going here. Okay, these next set. So for E, we have the book has a kind of an interesting name. They call it the reciprocal. Reciprocal function. All right. Now, we have and that is represented by f of x is equal to 1 over x. And what I was trying to say is that's another way to say irrational, right? That's a rational function, but they call it reciprocal. Remember, rational just means you can write it in fraction form. Okay, so that would have been for that one. Okay, for F there is called the greatest integer function, and that's represented by f of x is equal to, and it looks like two brackets like that. All right, so that's the greatest integer function. Sometimes you might also see it like this, int, and then with the brackets there. Actually, it doesn't have to be brackets, it can be parentheses. Okay. All right, so when you see that, that's the greatest integer function, and that is um, capital F there. Okay, and then for G, um, again, the book has some interesting names for these. So for this one, it is an identity function. But we know that as linear, right? So linear. Okay. So that's just a y is equal to mx plus b equation. Okay, for h there is called the cube root function. Okay. So this is the cube cube root function, and that's represented by f of x is equal to the cubic root of x. And then we have one more, and that is this line here. Okay. And that is the um, constant function. Let me pause here for a second. Okay, so this here is called a constant function. Okay, and um, that's represented by f of x equals b. So remember this here, that's just a horizontal line, right? So whatever that b is, it can be 1, 2, 3, whatever. Okay, so um, that is the constant function. Okay, so as you get familiar with these graphs, that will be great. So you're like, oh, I know what this graph looks like, and you're better equipped to um, finding that. Okay, the next page there is a piecewise defined function. All right, and I have a demonstration here. Okay, and I will clear this out. Hopefully you can see my demonstration. Okay, so we have a graph of a piecewise function, which basically means you're taking pieces of the graph and you're putting them together. Okay, so if we were to graph these three separate equations, okay, it will look something like this. But the key part about the graph of piecewise function is that it's defined at certain intervals. Okay, so can't move anywhere else. Okay, so for the first one, it goes from -3 to 0. The second one is only from 0 to 3. And the last one is from 3 to on. So let me just play this real quick, what I'm talking about. So here's the red dot. Okay. Right now, it's not capturing an image. Okay, because there's no image there. But once we get to -3, it's going to snap onto the first image or the first equation. Okay. And then that'll be graphed from -3 to 0. Then it snaps onto the second equation, and that's going to go from 0 to 3. And then last but not least, it'll snap on to the last equation, which goes from x is greater than or equal to 3. Right? So that's what we're going to be exploring next is these piecewise function. And it can be tricky for some students, but if we understand again the graph and what it does, then we have a better understanding how to apply the equations and functions there.